Hello and welcome to the New Mexico Bureau of Geology's informal lecture series. I am your host, Phil Miller, and today we're going to be touching on a pretty basic topic, but it's something that comes up fairly often. I want to start off by saying there are 3 videos already on my YouTube channel that cover the correlation of map units, description of map units, and their relationships together. Those are a little out of date, so we're going to need to go ahead and record those again. But once we do, that information presented in those new videos will better correlate with what is happening in this video. With that being said, the old videos still have good content in them. There's just a few things that are a little bit out of date with them. And what happened this week is I was presented with a topic that comes up fairly often. And it's, how do you make a correlation of map units? And one of the statements that I have made in the previous videos is digitizing them and creating a correlation of map units in a GIS is actually quite difficult. It's not as user-friendly. It's not as easy to work up. So one of the things that I commonly said and still say today is one of your best benefits is to work in a designer program or on a piece of paper or in like Excel to go ahead and build your correlation of map units. And the reason why I say that is because it allows you a quicker, more rapidly editable way to adjust your correlation of map units as you're building it. And you can see that there's a lot of information in here in this correlation of map units. It is dense. Building this in a GIS first would be extremely difficult and time consuming when it's much easier to go ahead and build it in a designer program where you can move boxes around as you see fit. So my recommendation has always been, draft this up on a piece of paper first. Get an idea of where all of your units are. Get an idea of how you think they should all fit together and what the relationship is. Figure out if you're going to need to do anything like scale changes so that you can adjust the height of boxes to make sure that labels will fit and ensure that, all of the features that you're trying to represent or are represented on your map have the ability to be displayed. And one of the other comments I'm going to make is this is at a 1 to 100,000 scale map. So we're going to start with that as kind of a foundational discussion point because it relates to the size of the boxes. And that's one of the things that we want to establish and make sure that we're always doing is our correlation of map units. The box width, the X direction of our map unit boxes, our polygons, should be 1/2 inch wide so that they're always universally the same size, the same width across the correlation of map units. The vertical expression of that is simply time. It's the deposition age range as we know it or as we think we know it. So one of the things to keep in mind is that vertical is related to deposition age. How long was this deposition? What is the geologic time frame that this unit was deposited over? So that it locks in what we know as being the range. Our vertical axis is going to be time. Our y-axis is going to be time. Our x-axis, this gets a little weird because there's lots of things we can represent. We can represent pinch outs and stuff like that. And coming up with a good value for what the x-axis represents has been a real challenge, and I've never come up with a good definition for what that is. One of the things that I commonly recommend on a correlation of map units is that if units touching, that kind of suggests that there is a interaction relationship with those units. But that isn't always the case, and I have a sneaking suspicion that in this example, not all of these units are touching each other or have a depositional relationship that's coeval with one another, but that could be a consideration. The x-axis is a little hard to pin down what it represents, but that y-axis is time. It is the time relationship of units. So, mocking this up on a piece of paper or in a designer program like Adobe Illustrator, or you can even use Excel to build boxes, is one of the key things that gets you the ability to easily adjust where your units are and get it all configured. And then this really makes the process of digitizing the correlation of map units super quick and super simple. It works out really well in the grand scheme of things to mock this up to the best of your ability in some program that allows you to edit quick. And for some of us, that's a piece of paper and an eraser. That is one of the quickest ways we can do things. But if you've done it in a designer program, there are a few things that we need to kind of pay attention to. And there are a few things that we want to get in the correct location. So we have been trying to build all of our correlation of map units and our cross sections starting at the datum location 00. The cross section is a much more stringent one, and that's because we have some scripts in the Bureau that really are run and designed to be run by finding the cross section at that origin location of our datum at 00. It makes the script much easier to write because it's always starting at a consistent location. So that's why all of our cross sections start at 00, and it makes it much easier for the script to get subsurface data when we're trying to incorporate it into like our aquifer mapping 3D, our 3D aquifer map projects. So starting at 00 is kind of a key thing, and it also gives it a consistent location so that we're doing things consistently throughout all of our maps. So the question then becomes, if we've designed this in a designer program, how do we make it and ensure that these boxes stay a ½ inch wide? Well, that's where determining the location of this and getting this referenced to a location assists us in duplicating our ½ inch wide boxes here. So that would be something that we would want to check. We would want to make sure that these are ½ inch wide. And it looks like they are pretty close. I would have started this in a couple different locations to ensure the ½ inch wide, but there's also ways we can fix that. Let's just take a look at this. Yeah, so its width is 0.4958, so really close to that ½ inch wide. It's okay if they aren't perfectly a ½ inch. There's some things we can do to fix that, just like there's things we could do to fix these overlaps. And when they aren't meeting at exactly the same spot and possibly should, this would be an author question. I'm not sure if the deposition age is known so tightly to know that, you know, a couple, maybe 10 years is enough to be able to separate these. My sneaking suspicion is the author would want all of these in one consistent line across the bottom. We can fix a lot of that in our GIS when we set it up. So getting it configured this way gives us the best ability. I'm not sure what that is. I hope that wasn't me. This gives us the best ability to go ahead and align things top and bottom, left and right. We can see that we've got some overlapping here happening in a couple different places that isn't perfectly overlapping. And in our GIS, we would kind of like those to be tight and tidy so that they overlap perfectly. But that is much easier done in the design in the GIS. This is easier to go ahead and grab the boxes that we need, move them to where we need them to be, and work with them in that function. So that's the benefit of this. In the GIS, we'll want to make sure we're aligning things a little bit tidier. But that's exactly why we're having this discussion. Is the question is, how do we get this georeferenced in a GIS so that the boxes are at map scale a ½ inch wide? That is the tricky part, and it's really not that tricky when you think about it in its most basic terms of what we're trying to do in a GIS. So there are a couple tricks that we can start off with, and then there's some math that we need to do, and once we've got that all configured, this process is actually quite simple, but we need to know the tricks. So that's what I'm presenting today, is the tricks for getting this georeferenced from either a designer program or whatever it is as a PDF. That's the comment I'm going to start with, is a TIFF, sorry, as a TIFF, to get this as a TIFF so that we can easily get it georeferenced so that we can then go through the process of digitizing this in a GIS. So first and foremost, we can see that this has a width and a height where it's something like 13 inches by 16.5 inches for our page size. We can do it based off of page size, but then we're going to be a little bit more arbitrary. We can tie this physically to a width and height of the actual objects, which also helps us tie it to the height and width of our GIS georeference. So this will probably not make sense until you actually see things happening. So I'm kind of just going to jump right into it, but I wanted to give a little bit of a preface and start off giving some information to help understand what this is. So one of the first things I need to do is I need to know how big this is. So again, we said, 13 by 16 and a half. There's a couple of things we can do. We can georeference it to that dimension specifically, or we can georeference it to the dimension of our physical boxes ourselves. But what we need to georeference is like 4 corners, right? We need 4 locations so that we can stretch this image to a specified distance, a specified dimension. So I'm going to start off by doing kind of a generic method that works. There's multiple ways you can do this, but I'm going to do the generic first because it should make the math a little bit easier. So what I'm going to do is I'm going to go ahead, and since we need 4 corners, we don't have a corner down here. We don't have a physical object that we can georeference to. So if I zoom into this corner, if I export this as a TIFF, we don't get a neat line around the edge of this. We would only get white space here. And white space, there's nothing that we can georeference to. So what we want to do is create a physical box that gives us a stroke so that we can physically see the dimensions of this box. So I pushed the M tool, or you can click on the rectangle tool. I'm going to snap to the bottom of the corner, click and drag my box to be the full width of the page, making sure that it's snapping to my corners. And I go ahead, now I have a black box. I'm going to hit the X key, or sorry, Shift X, which flips it. So you could see that I had a black box with no stroke. I hit Shift X and I flip that. Again, this is a specific thing to Illustrator, but what we want is that outline. And what I'm going to go ahead and do then is make that stroke something a little bit obnoxious. So now it's 2 point, so that it's physically visible when we're working on the CMU. So now we have a box around the edge. And in this white space, we have a box, something we can physically see when we export this raster. The other thing that this gives us is a physical dimension. So we can see this is 12.9829. I'm going to call that 13, and 19.0175, and I'm going to call that 19. And so what we're going to do really quick is I'm going to go ahead and open up a, let's do, I don't know if I have Notepad++. I do. I'm going to go ahead and open up, a Notepad really quick. Let's make a new document. And so we know our map scale is 1 to 100,000. That physically represents a relationship of the map size to the real world size. So I love using the dimensionless version, 1 to 100,000, because it is unitless. And what this says then is 1 unit is equal to 100,000 units on the ground. So 1 unit on the map is equal to 100,000 units in the real world. So if I say 1 inches, it's 100,000 inches. If I say 1 centimeter, it's 100,000 centimeters. This works really well in trying to determine what we're working with, and there's a very simple formula to figure out what our dimensions are of our different features. So if I set this equal to some dimension, and then we know that the width of this is 13 inches, divided by x, I can then solve for x to determine how many inches we need our box to be in the GIS in the real world. Again, this is a real world value. So I'm going to go ahead and Okay, sorry, I needed to go grab my calculator so I could run this calculation without making arithmetic errors, so I wanted to make sure I did this correctly. And if we solve this equation for x, what we get is x equals, let me make sure I am reading that correctly, 33,020 meters when we factor in the conversion from inches to meters. And then we have another one that's 1 over 100,000. And we know our vertical dimension is 19 inches. And we're going to divide that by our real world. And when we solve for x and convert to meters, we get 48,260 meters. So now we know what our physical dimensions of this map area, this CMU extent is. We know that it's 13 inches by 19 inches, and when we convert it to a 1 to 100,000 scale, we know that our x direction, I should have solved for y, let's do that so that it's clear, there. So our x direction is going to be 33,020 meters, our y direction is going to be 48,260 meters tall. So now we've got the physical dimensions at 1 to 100,000 that duplicates these at map scale at half-inch wide boxes. So we've proportionally set this up to be a page size at 1 to 100,000. And a lot of people ask, why do we do that? It's a simple process to make sure that all of our maps are exported at scale. So we don't want to set it to 1 to 1, we want to make sure that everything is proportional, and it's a quick, easy thing to set all of our data frames to be at the scale of the map, and then we have less that we need to pay attention to, like, oh, does this data frame need to be at 1 to 1? Does this data frame need to be at 1 to 100,000? We just set them all to 1 to 100,000 or 1 to 24,000, and then it makes it much easier to lock in, and then we don't have to worry about the georeference. When we load this image in, we can actually set it to a size and specify that size and dimension. So we've done the math now to figure out that this is 33,020 meters wide and 48,260 meters tall. So I'm going to go ahead and move that off to the side, keep that in my mind. We now have our box that's 13 by 19, and what we want to do now is save this as an image. So I'm going to say File, Export as. I'm going to go ahead and save this as a TIFF. This is all fine. I wouldn't worry about too much about this. We're trying to do this as a reference image. So now I've got my TIFF, and now what I can do is there is my image. I'm going to drag and drop it in. And one of the first things that we notice is we get a warning that says unknown coordinate system. And it's because this doesn't have a coordinate system. And that's the solution that we're actually trying to remedy. So if I zoom to that layer and we take a look at this, there is our feature, our image of our correlation of map units. And I'm sorry, I'm looking for... I'm not seeing... Let's just go ahead and... Oh, it was right in front of me. Oops. Okay, so I'm going to then go ahead and measure this, and we can see that it comes in at 0.5 meters. So if we were to digitize this as it comes in, our scale is 1/2 meter instead of 1/2 inch. So this is the reason why we're trying to get this locked in a more logical sense that really physically makes it a size and dimension. So we know then that this isn't at size, so we shouldn't go ahead and digitize this right from the scratch. We should go ahead and make a box that is the dimensions that we specified, that 33,000 by 48,000, so that we have something to physically georeference these corners to. And this is why we added in these corners, is to allow us to have a physical feature to georeference this image's box to our box that we create. So what I need in order to draw that extent of our correlation to map units, the extent that we want this image to fit to, is we need the Socorro CMU layer file. So I'm going to go ahead and add that layer file in, so that we have the feature CMU cartographic lines. And in the CMU cartographic lines, we have a template guide. This is literally the template guides that we want to build in order to get everything lined up and configured well. So if I go ahead and click on the template guide in my Create Features, there's a few tools that we have at our disposal that allow us to directly place vertices at specific locations using this template guide. So if I right click on it, we can set an absolute XYZ. We can use our direction function to draw in a specific direction. We also have delta XY, which will do a change in direction and distance. We can do a direction and distance specifically. We can do circular arcs, etc., etc. Most commonly, I use direction, absolute XY, or delta XY. Those are the three that I tend to use most often. And the nice part about the direction and absolute XYZ is I have hotkeys for those. So if I hit Shift A, I can do my direction, and if I hit the F6 key, I can go ahead and do my absolute XYZ. And it'll become really obvious when I'm doing this how this functions, and I'll call out the different keys that I do. So what I'm going to do first off the bat is I want to start this at 0, 0, 0. So it starts at a location, 0 X direction, 0 Y direction, and 0 Z direction. So if I click on that, I can type in 0, 0, 0, because I set my units in my project options to be in meters. I physically put them at that location then. So if I hit enter, I now have a physical vertice at 0, 0, 0. And we know that we want to go vertically because we did the math to prove this. We know that we want to, again, consult our notebook. We want to go in the Y direction, 48,260 meters. So what I can do now is I can specifically pick a direction, Shift A, pick a direction that I want to draw in, and I want to go up 48,000 meters. So I'm going to put it at 0 north as Mosul so that it's automatically going up. And what this does is it locks it in. No matter where I move my cursor, it is locked into that 0 degrees direction. It physically is locking it in that orientation. I can't accidentally make it go at any other angle. What this allows us to do is a quicker way of getting in that absolute XY because it picks up where the cursor is. So if I right click and come into my absolute XYZ, it knows that it's locked in that X direction to 0, so it doesn't input any X offset to this line because I've already locked it into the vertical. So what I can do then is just type in that vertical dimension that I want to go to, the absolute X0 Y at 48,260 meters. So 48,260 meters. When I hit enter, it goes ahead and moves and draws that line, that vertice, at that location. And if we hover over it, we can see now that, I've got it in decimal degrees, so that doesn't help. But if I had my units down here in meters, we would see that that is at 48,260 meters. And the same is true for going over. We can do the same exact function. So I'm going to hit Shift A to throw a directional to lock it to 90 degrees perfectly. North is Muthul. No matter where I move my cursor, I am locked into that direction. I'm going to go ahead and hit the F6 key, or again, right click absolute XYZ. We are locked into being vertically at 48,260. All we need to do is set our X offset that we're going to. And in this case, it's 33,020 meters. I hit enter. We draw that vertice at that 33,020 meters X and 48,260 Y. Now we're going to go back down to 0 in the Y direction. We want to stay locked into that same X direction. So again, I'm going to hit F6 key. And you'll notice that it doesn't have those dimensions because I didn't put in the directional. So this is where that directional comes in really handy, but since we've got our units, I don't have to worry about it. I can physically type in where I want to go. We know in the X direction we want to stay at 33,020. We know our Y direction, we want it to go down to absolute 0, back to 0. And when I do that, it locks it in. There's a couple of different ways that we can do this. So again, I'm going to show the directional method. I want to go 270, lock it in. I can then come over here and snap to, and I can double click and do all those things. But again, I want to hit the F6 key so that we can see we want to go to X at 0 because we're going back to 0, 0. And when I hit that, I get back at 0, 0. I hit F2 to finish my sketch, and now I have my neat line. I'm going to save those edits. I'm going to clear my selection. So now I've got a neat line that I can georeference to. And again, there's a couple different ways you can do this. Play around with using the directionals to help you figure out how to do this to get the values that you want. I strongly recommend you play around with this. It takes a little bit of time getting used to, but you can see that I could physically put in those dimensions. And since I calculated those dimensions that we needed, I know this is locked in and perfect. So now what we want to do is georeference this image to this box that we've created. And the good news is because it didn't have a spatial reference, when we started, it almost came in perfectly where we wanted it. So what I'm going to do is we're going to go ahead and go to the georeferencing toolbar. And what I want to do is I want to add control points, and I'm going to lock this in a little bit tighter. So I'm going to click what I'm georeferencing and then click what I'm georeferencing to. So the image to my box. I click and we can see it moves over. And then this is actually going to be really simple to do. So I could do this corner to my northwest corner, but I'm going to go cross corner. I always recommend doing this because it should help the stretch be more consistent. So I'm clicking the source from point and to point. So where are we going? Here is, we want this point source. Zoom to layer. Oops. To go to this target location. I click that, and now we can see that already it's starting to stretch to the size that we want, and we've done it very simply by georeferencing to a known box. So the box to the box. And if it wasn't for this neat line, could you imagine trying to find that location of the source? It'd be really hard. That's why we made the neat line, is so that we can use it to our advantage. So I'm going to go ahead and I need to zoom in more. Click what I'm georeferencing and what I'm georeferencing to. Now I've got those locked in, and that should be good enough to get us what we need with regard to getting that set up. So then what I want to do is I want to save as new. We'll save this in our repository rasters folder because it's georeferenced. So I'm going to call this Socorro CMU. Oops. RECT to define this as a rectified TIFF. We're going to save it as a TIFF. We're going to add the coordinate system now, because now when we save this georeferenced image, it will obtain a coordinate reference system. You remember when that warning popped up that said we had no coordinate system for this image? This is what we're fixing. This is one of the things we're fixing. Clipping geometry, that's all fine. 8-bit unsigned is fine. Compression type, I tend to do LZW. We'll go ahead and export that. Calculate statistics. I can now remove my draft image. And now I've got my rectified image locked in here. Okay, so we did it to the absolute extent of that box, which does not put this corner at 0, 0. So that's one of the other things that I may have done to get this locked in to be at a specific location. But it doesn't really matter in the grand scheme of things, because we can fix this retroactively. And the reason why we're talking about this is I want this box to be a 1/2 inch wide. I would like to make me some guides and grids that help me do that. So we could have made the box perfectly to the dimensions that we wanted, starting here. Here, so that it's at 0, 0. So that this box starts at 0, 0, and then we can go over and 1/2 inch. It's harder to come over a 1/2 inch from here to know that we're going to line up perfectly at 0. But this is why, but we can think of the cartographic line as a temporary thing. I'm going to delete that. It served its purpose. It allowed us to georeference this image. What I can do now is build that box that I want to here to the dimensions that what we need as a starting point. So I'm going to go ahead and come to my cartographic lines, create my template, and I'm going to start right here. I'm going to click my vertice, and then what I'm going to do is I'm going to go over 1/2 inch. So we need to now know what 1/2 inch is in our 1 to 100,000 scale map. So again, we pull out our handy dandy notebook, and we know that we want at 1 to 100,000, we want to solve for this equation. So let me go ahead and plug that into my calculator. So at 1 to 100,000, a 1/2 inch box is 1270 meters. So that's what we need to input into our directional and absolute XY, 1270. And the reason why I talked about our delta XY is for this factor right here. So I want to throw a directional, so Shift A. Oops, activate the right window, Shift A. Now, I want to go in the horizontal axis. I want to go 90 degrees. I want to go 90 degrees. And then what I'm going to do is I'm going to right click and I'm going to do my delta XYZ. And when we want to go delta X 1,270 meters. So delta X 1,270 meters. I hit enter. Now that's a ½ inch box. And we can see that these boxes are not a ½ inch. These boxes look more like a ½ inch. These boxes more look like a ½ inch. So we already have an issue with this not being set up to ½ inch wide. So this is why it's really good in your designer program to fix these problems beforehand, because now we have to fix it in the GIS. So what I'm going to do is I'm going to continue marching over 1,270 meters so I can have a whole bunch of vertices that I can then lock to vertical lines. So again, Shift A, I'm going to do 90 degrees. I'm going to right click. I'm going to do my delta XYZ and it's 1,270. I'm going to copy that so that I have that. I'm going to enter. Again, Shift A. 90 degrees, delta XYZ, 1,270, Shift A, and you can see this is a little tedious and there is a trick for this, but I want to talk about this in the simplest terms so that everyone can understand and see what I'm physically doing, so that there's understanding what is going into this process. If you wanted, you could create what's called a fishnet, and I don't know if that's what it's called in Arc Pro, but there's the fishnet tool that would build you a grid of boxes in the X and Y axis that are spaced out. You could make them ½ inch by ½ inch boxes by typing in those dimensions. But I wanted to keep this simpler because that tool is not the easiest tool to use. It becomes much easier when you've used it a couple times, and I wanted to keep this in the simplest terms so that it was easily understood what I was physically doing. So now I've got those spaced in a way that gives us what we need. What I'm going to do is lock this into, the vertical. And then I'm going to come in here, and this is where it'd be nice to have this as a tight line to know what that is. But it's okay. I'm going to go ahead and make this too long. And then we're going to do a similar thing over here. So what I'm going to do is I'm going to select this feature, right click, edit vertices, right click. I want to reverse my direction, and then I'm going to continue this sketch. So now I'm drawing from here instead of from here. I'm going to go ahead and do the same thing. Throw a directional, lock it into the vertical, make it too long, double click, and then what I can do is I can pin this top part. Oops, I need to change my order. Then I can pin this top part to this 0 KA and make my horizontal. Again, that's that same distance, or I can be lazy. So I'm going to select this line. I am going to come to my editing. I am going to split this at this vertice. I'm going to go ahead and split it down here as well at that corner. I'm going to clear my selection. Now all I'm grabbing is that bottom line. There we go. Copy, paste special into the layer, cartographic lines. Now I've got two of them. Now I can physically use the move tool to move that line up here. The problem is I can move this in any direction. That's one of the bad things. So I'm going to try and set it right at the top. There, now they're all selected. There we go. Now I'm moving the whole line. And now I should be able to snap to, there we go. And now I've got my grid across the bottom and the top. And what I can do fairly quickly now is set myself up to have template grids spaced every ½ inch. And now we can see what size things need to be in order to get the boxes to fit in. So these all work good, but we've got two problems here with these boxes not being exactly the right dimension that we want. And we'd have to fix that either in here or in the designer program itself. But then if we really want to be persnickety about everything, we can go ahead and click this, edit vertices mode, and snap that vertice to that intersection and endpoint, and we can do the same to this one. And now we've got a nice tidy grid that allows us to start georeferencing things too. We can also start georeferencing in where our scale changes are, so that we can put in horizontal lines that help us understand where our features are. So we can see that there's a direct correlation across here to these. So if we were to create a horizontal grid, throw my directional at 90, and now I can lock it in to that horizontal. Now we can see that some of these aren't perfect, so maybe we want to get rid of this part of the line in the areas that don't apply. But we can also correct this issue right here. So I can see that this should drop here. I can throw my directional. Oops. Snap to my grid. And now I've got that baseline that I need these to all touch. And then I can start coming to my contacts and faults and digitize in whatever features I need and snap to all of my grids so that I have these in the right way. The one thing you're going to want to do with that when you're working with the cartographic lines is you'll probably want to move it below contacts and faults so that when you digitize an actual contact and fault, you can see the line on top of your grid. And that's a bad example until you zoom in. So it might also be a good time to go ahead and go to my raster layer, set it to be 50% transparent, and now you can see the neat line, the contact that I drew in on top of the cartographic lines. If you need to, you can also adjust this to make it thicker so that you can see that neat line over the top. You can see the contact over the top of that neat line, the guide, the template guide, over the surface of it. So that's how we georeference and rectify an image so that we can digitize our correlation to map units. And you can see how easy this does make it now, using this to go ahead and digitize what you need to in your map so that you can get everything snapped and tidy to your grid and guides and use those to your advantage. I hope this video has been helpful, and I apologize for being a little discombobulated and discontinuous with things, but I hope this helps you understand how to get that georeference and what you need to get georeference. So let's recap that. If you design your correlation and map units either by hand or in a designer program, draw a neat line around the edge so that you have a physical feature that you can georeference to in the GIS. Then, once you have that neat line, find out what the dimensions of that neat line are. Do the conversion to figure out what that box is at map scale. And once you have those numbers at map scale, you can go ahead and build you a box that is that same size scaled for the 1/2 inch wide hand-drawn or designer program that you can then georeference to in ArcGIS. So that's why we created this box to these dimensions. We figured out what our actual designer program dimensions were, and then solved for the physical dimensions on our world for the scale that we're mapping at. And then georeference the TIFF image to the GIS box, and then you can have that georeferenced and go ahead and build your guides and grids. I hope that makes sense. I really realize it's a hard topic to talk about in trying to explain it. I hope that the visual is the clue that helps you understand what we're doing, because I think without the visual, this is harder to describe and explain to most people. But once you see the physical visual of what we're georeferencing and what we're georeferencing to, I think that makes it a simpler way to understand how we get these in. And then if you build your boxes at 1/2 inch wide in your designer program, you know that when you georeference this, everything comes in already at the right proportions for making a consistent correlation in map units. I hope this has been helpful, and we will talk to you all later. Have a great day.